Hospital management could be a complex problem due to the large amount of patients' data and diverse management processes. In this AI-driven application, we provide examples of analyzing historical patients' data and some methods of protecting sensitive information. Then we trained machine learning models for predicting the length of stay and readmission risk. Let me walk through each part of the dashboard. The first part is created from the patient's visiting data, which contains more than 200,000 records. We can find the details of each patient's entire journey in the hospital, starting from the registration until they discharged. When we select a patient ID from the table, we may find that this patient had multiple visits in the history. So the patient journey chart on the right side will show all the important timestamps about this patient visit. On the top, we created two KPI metrics to showcase the waiting time from admit to triage and from triage to consult. It is important to understand the average and the maximum waiting time, as well as the trend. We use the color gradient to show the health condition. The greener, the healthier. If the waiting time is longer than the defined benchmark, the color would turn red. We can also understand the trends of the number of patients registered and try to find the peak hour of the day. From the control panel, users can do more filtering and selections to narrow down to more specific type of patients. In the second part, we applied data masking for protecting some sensitive personal information. For example, the middle characters in the race and the patient county columns have been replaced by a random number of the X characters. And in the patient zip column, those numbers have been treated as strings, and we permutate the order of each character to randomize the order of the string. This data masking was achieved by a Python function, so we can write some simple Python code inside of Spotify to do the randomization and data masking. The other method we can apply is using the k-means clustering to group up the patients with similar attributes. Then we can use the k-means labels to represent the private information to some extent and use the labels as predictors for training a machine learning model. Moreover, we can use the map chart or some simple pie charts to aggregate information and show the personal information at a high level. Moving to the part 3, we can see more results of predicting the length of stay. We trained a machine learning model in the data science platform. From the dashboard, we can click this button to trigger the workflow. We implemented model validation that users can compare the predicted value to the real ones, and they can also see the predicted results for the test data. We did feature selection based on the correlation, and we can check the model summary to understand the coefficient and those p-values. In the end, we can aggregate the predicted length of stay results for the test patients by different attributes. For example, we aggregate the results by the arrival type here. Let me explain more about what we have done on the data science platform. We created several workflows to complete the analytical life cycle. We started from data preparation to join different datasets, clean and create labels and features. Then we had this data exploration workflow to help us understand more about the distribution and summary statistics of those features. We created another feature generation workflow for preparing for the modeling. As we can see on the dashboard, those correlation filtering results come from this operator. We built multiple workflows to train models for different use cases. When users click the buttons on the dashboard to trigger the modeling workflows, these operators would send the calculation to the Spark cluster and bring the results back to the dashboard. These operators would send the calculation jobs to the Spark cluster and send the results back to the dashboard. In the last part, we analyzed the readmission risks of patients. Readmission is usually defined as the patients coming back within 30 days. The higher readmission rate can negatively impact cost and patient outcome for the hospital. We tried both the logistic regression and gradient boosting algorithms to build the binary classification models. Those models are also created on the data science platforms. By clicking the buttons here, we will train the models independently. Since this is a binary classification problem, the models will tell us the probability of the readmission. Hence, we can use different color gradient to highlight the different risk levels. We can also use a heat map to compare the readmission risk over different conditions. In summary, this customized dashboard can help the hospital management admin to find more insights from the historical data and train machine learning models from the data science platform easily to predict the length of stay and readmission risk.